Hello, welcome. So today we'll be seeing the question called linked list cycle. Question number 141 from lead code, linked list cycle. So let's read the question, let's understand, let's see what are the approaches that we have, and let's try to solve this question. So given head of the head of the linked list, determine if the linked list has a cycle in it. So basically they're saying that they'll be giving us a head. They'll be giving us a head. Now we need to say whether this linked list where the head is given contains a contains a cycle or not. So let's see what does the cycle term and like what exactly they're going to say. So there is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. So they're saying by moving next like this, is there any node in the list that can be reached again? So is there any node? So we need to see, is there any node in the list by moving next, and its next is this one, can be reached again by using this next pointer. Internally, position is used to denote the index of the node. The tail's next pointer is connected to, okay. Internally, they are using position, which is connected to the tile's next pointer. So note that position is not passed as a parameter. So don't even worry about these things, guys. They're not even passing and they just gave this as an example. So nothing to worry about. So at the end, we need to detect whether it is a cycle is existing or not. That is what we need to do. We need to return true if cycle is there in the linked list, else false. Very simple one. So let's take one example. Let's see the example that is given by them. So yeah, here that is very clearly mentioned. So first thing is 3, next thing is 2, next node is 0, zeros next is -4. Again, if you observe, -4 next is 2, which is already visited by us. We have already marked this. So this example contains a cycle. This example contains a cycle, which means we need to return true. We need to return true, guys. So this is what they're saying. So by following, going next, is there any node which we can visit again? That is what we need to find out. I hope this question is clear. So even in the example, that's what they're mentioning. So there is a cycle in the linked list where tile connects to the first node, basically this node, node 2. And this also, you can see it has a cycle and this doesn't have a cycle. So the number of nodes in the list is in the range of 0 to 10 power 4, which means we can get 1 lakh values, 1 lakh number of nodes, and the values can be positive and negative and valid index in the linked list. So this we don't even worry about. So let's see how to identify whether it has a cycle or not. So any idea, guys, that you are thinking about, just give it a thought. Pause this video for a second, give it a thought. What exactly we can do? What exactly, which data structure I can use? Which things we can use? Just give it a thought. Pause for this for 1 second. Okay. I hope you might have thought of one or two approaches. So let's see what we can do here. So this is the given linked list, right? This is the given linked list. Now from this given linked list, I know, okay, what we need to do, what we need to do. This is the given linked list. Okay, we need to say whether it has a cycle, which means if we visit the same node. So if you observe, I am going to 2 from 3, and also after going to 0, after going to -4, now again I'm going back to 2, which means if I visit a node, if I visit a node second time, then if I visit a node second time, then that node indicates me it contains a cycle. It contains a cycle, guys. Okay, I hope you are getting the point. If I am visiting this node, if I am visiting this node twice, in this example, I visited this 2 from 3 and also from -4. I'm also from -4. That's why this node will be the, like this linked list is a cycle. Okay. I hope this is clear. But how you will identify whether I visited this or not? How we can identify? How we can identify? So what we can do is we can store node address into a hash set or hash map, whatever it is. We can use this hash set and we can store node address into this hash set. So let's give some addresses to this every node. Let's say three's address is A, three's address is A, two's address is B, zero's address is C, 4 minus 4 address is D. Minus 4 address is D, guys. Now, what is the next node of A? Next node of A is B. B's next node is C. C's next node is D. I hope this is clear. Every node is associated with the address. Just for our purpose, guys, internally they will not store A and B addresses. Internally, it has some value which is memory address. So, for our purpose, for our understanding, we are using this A, B, C, D. Okay. Now, I am at first node, which is my A node. So, which is value 3, which is value 3. I will store address of this node into hash set. I will store address of this node into hash set. Okay. Now, what I will do again is I'll go to my next node. I'll go to the next node, guys. I'll go to the next node. Okay. I'll go to the next node. I have stored address of A into my hash set. I'm going to the next node. What is address of this node? B. Address of the second node is B. First thing I will do is check. I will check in the hash set. Do I already have this? Why I am checking? Because it might form a cycle. It might form a cycle. So I will check in my hash set. Let's say this is our hash set. Hash set. I will check. B. Do I have B in my A? I mean, in my hash set? No, I only have A. So I don't have this hash set. I don't have this node in the hash set. I will simply store this node B. I will simply store this node B. Again, I'll go to the next node. I'll go to the next node. Now I have 0 is the value, C is the address. So I will check in my hash set. Do I have C? No, I will store it. It is not there. So I can store it because this, why I am storing? Because this might come in the future. That is the reason, guys. We are not storing this randomly. We are storing this with the purpose of it might come in the future. Now I will go to next node. What is the next node? Its next node is connected to minus 4, which is D. I will check. Do I have D? No, I don't have D. So I'm adding D. Again, what is the next node of D? Minus 4 is linked to node B. So minus 4 is linked to node 2, value 2 or node B. I'll go to this node. I'll go to this node. Now I have B again. I will go and check in my hash set again. Do I have B? Yes, I already have B, which means I already visited. I already visited. So what we will do? We will simply return true. We will simply return true. So whenever you are checking in the hash set, if that node is already there, simply return true. Simply return true. So we need to do this process till we reach at the end. If you are not reaching the end, obviously in between we will return true. If you are reaching the end, we will to return false, which means all the nodes are unique. All the nodes are unique. I hope this brute force approach is clear to everyone. So let me open and type this one. Let's type this one, guys. What was the first thing, guys? Go to each node. What is the first thing? Going to each node. After going to each node, what I need to do? Check in hash set. Check in hash set. If exists, return true. Return true. Okay. If exists, return true. Else, add into hash set. Add into hash set. How many times I need to repeat this process till like I need to go to each node, which means I need to go to all the nodes. After completing of the entire process, I need to simply return false. Why I am returning false? If there is a cycle, I will find out here only. I will find out here only because My hash set works in that way. I'm going to each node. If I have a cycle, I'll find it here, I'll return row. If not, I'm adding it into the hash set. So this additional adding, what I will add here, I will add node into the hash set. So that's why I will figure out here itself if it is this cycle. If not, I'll return false. So these are the 4 steps that we need to follow, guys. I hope this is clear. The brute force way of solving this one. Now, what we will do is, let's see the optimal way, or let's see what is the another way to solve this particular question. Another way to solve this particular question. So give me a moment. Let me open this one. Let me create a linked list. 1, 2, 3, 4. 4 is linked to 2. 4 is linked to 2. So if you observe, I have node 1, which is linking to 2, node 2 linking to 3, node 3 linking to 4, node 4, which is linking to node 2 again, node 2 again. So now if you observe, there is a cycle. But how we can say? How we can say there is a cycle? So here comes our approach, tortoise and hare approach. 2 pointers, slow and fast. Slow and fast. What we know about slow and fast is these pointers, slow will be moving 1 step, fast will be moving 2 steps. So whenever they are in a cycle, okay, let's say there are 2 people. Okay, you know clock, right? You know clock, where it will have short hand, it will also have long hand. Even though long hand is going faster, even though long hand is going faster, it will meet shorthand at least once, right? Obviously, it will meet every 1 hour. This shorthand will, like, the long hand will be meeting the shorthand. Okay, when I say shorthand, this is hours. When I say long hand, this is minutes. I hope everyone knows how our clock works. So if you observe, even though shorthands move only 1 time, like for every hour, if you observe the long hand, it will go very fast. So your hours will go slow, your minutes will go fast, right? Yes or no? Your minutes will go fast, which means your minute hand is moving faster. Even though if it is moving faster, this will at least meet hour hand once, right? Yes or no, guys? So the same logic approaches here. So whenever something is in a circle, either they are going slow or fast, they'll meet at least once. That is the ideology here. So what I will do, I will move my slow and fast pointers. So now as a first step, slow will be going to 2, slow will be going to 2, fast will be going to next of next, which means fast will be going to 3, fast will be going to 3, again slow will be going to next step. So how many times we will do this process till fast reaches null, or fast dot next reaches null. We will come to this condition, but before that, now slow came here. Now fast will go to 1 step to 3, and second step to 2 again. So now fast reached 2. Again, slow will be moving to which pointer? Slow will be going to 4. Slow will be going to 4. Fast will be going to 3. And from 3 it will go to 4. From 3 it will go to 4. Now if you observe, slow and faster pointing to which one? Slow and faster pointing to node 4. Slow and faster pointing to node 4, value 4, which means there is a cycle. There is a cycle. If they are not in a cycle, fast will reach, what fast will do? Fast will reach the end. Fast will reach the end, guys. So I hope everyone understood this slow and fast approach. This slow and fast approach works in the way our clock works, where minute hand will be meeting hour's hand at least once. Okay, this is what the approach is, guys. We will move our slow pointer 1 step, fast pointer 2 steps, and we will continue do this till, if they are meeting, till fast reaches the end, guys. So now let's complete this one. Let's try to code this one. Let me open this, guys. Let me code this one. As we said, we have 2 pointers. What are those? List node, fast pointer, slow pointer. They are pointing to fast is pointing to head, fast is pointing to head, slow is also pointing to head, right? And slow will be moving how many steps? Slow dot next one step. Fast will be moving fast dot next two steps. Now what I need to do, I need to repeat this process how many times? While fast is not equal to null, fast is not equal to null, and fast dot next is not equal to null. Fast dot next is not equal to null. So we will move in this way. We will move in this way. So while fast not equal to null, slow not equal to null, we will simply move forward. Whenever we are moving, if slow and fast became same, simply return true. Simply return true. Else, if you are coming out of this while loop, which means return false, return false. Okay, so we are moving one step slow pointer, two steps fast pointer. If they are meeting, we are returning true, which means there exists a cycle. If they are not meeting and fast pointer reached the end, which means we don't have a cycle. Return false, return false. Let's run this code. So this got successfully submitted. This got successfully submitted, guys. I hope you understand the approach and code for this particular question. This is the optimal way of doing this one. We also can use hash map, but using this fast and slow pointers is the optimal one. This particular fast and slow pointer works in such a way the our clock works. Our clock works. I hope this is clear. Thank you, guys.